Hello everyone, so we're just going to finish our 1.5 notes from yesterday. If you recall, the last thing we were working on was estimating square roots of numbers that we can't nicely take the square root of. So this is the one I had you guys try at the end of class. Let's go ahead and go over it as a review. We want to estimate to the nearest tenth what the square root of 54 is. So what we want to do is we want to find two perfect square numbers that I can take the square root of that that is a little bit less than the square root of 54 and higher than the square root of 54. So just a reminder of what my perfect squares are. We said the square root of 1 is 1, so 1 is a perfect square. The square root of 4 is 2. 2 is a perfect square. So is 9, since the square root of 9 is 3. And 16, square root of 16 is 4, 25, square root of 25 is 5, 36, square root of 36 is 6, and then 49, square root of 49 is 7, 8 times 8 is 64, so square root of 64 is 8, and square root of 81 is 9, square root of 100 is 10, square root of 121 is 11, and the square root of 144 is 12. Right, so if we look at the square root of 54, it looks like the square root of 54 is between the square root of 49 and the square root of 64. Okay, because we know that the square root of 49 is 7. This is 7. The square root of 64 is 8, I know it's going to be 7 point something, right? 7 point something between 7 and 8, and so we can use a number line to help us estimate, and then we can try to test it out. So if I put the square root of 49 right here, which is 7, and then I put the square root of 64 right here on the number line, which is 8. There are, between 64 and 49, there's a difference of 15, so there's 15 units between the square root of 49 and the square root of 64, and so half of 15, that would be 7.5. And so 7.5 away from 49 would give me, if I add 7.5 to 49, that's going to give me 56.5. So in between 7.5, which is between 7 and 8, is roughly the square root of 56. Okay, so it looks like the square root of 54 is going to be less than 7.5. So we're going to estimate 7.3, 7.4. Either of those will be acceptable if you put 7.3 or 7.4. And then all we have to do is check it. So if I did 7.3, we just have to multiply to see if 7.3 times 7.3 would give me roughly 54 back. That would be 9, 21, 21, and then 7 and 7 would give me 49, 50, 51, and when I add, okay, that gives me 53.29, which is pretty close. So to the nearest tenth, we're going to say that the square root of 54 is roughly 7.3, and if you put 7.4, that is also okay. And because we're estimating, we don't use the equal sign, we use these approximate symbols. Right, so let's take a look at the next part. Identify the number that does not belong with the other three, so think about that for a minute. You can pause the video if you want and try it before watching. And then, so the only one that does not belong will be the square root of 81, which is 9, because that is a rational number. Whereas all the other ones, the square root of 21, square root of 35, square root of 67, are not nice integers that we can take the square root of nicely. If we put all of those into our calculator, these are all going to give me decimals that don't end and don't repeat. So all three of these are irrational numbers. And the square root of 81 is the only one that's rational. And the very last thing we're going to look at today is how to rewrite a repeating decimal as a fraction. There are some repeating decimals that you already know what it is as a fraction, right? So for example, 0.33 repeating, you know that's 1/3. 0.66 repeating, you know that's 2/3. So any repeating decimal can be written as a fraction, and I'm going to show you how to. So example 2, we're going to try to rewrite 0.777 repeating into a fraction. And what we're going to do is we want to figure out what this is as a fraction x, right? I want to see what this equals, and x is going to be the fraction I'm going to try to rewrite it into. So the first thing we're going to do is write an equation. I'm going to say x is equal to 0.777. That's what I'm trying to figure out, what x is. And then I'm going to multiply the equation that I just wrote by a power of 10 that will help me move the decimal over. So for this one, I'm going to multiply my equation, the left and the right side, by just 10. So on the left side, it's going to be 10x. On the right side, when I multiply 0.77 repeating by 10, the decimal place, when you multiply by 10, moves one space to the right, and it becomes 7.77 repeating. Okay, and that's also repeating. And the purpose of doing that is so now I can go ahead and subtract these two equations. 10x minus 1x is 9x. And then the 0.77 subtract away, 7.777 minus 0.777 is just 7. And then we can solve for x. Divide by 9. X is 7/9. So 0.77 repeating as a fraction is 7/9. Okay, let's try to do the same thing for 0.2727 repeating. So I'm going to say x is equal to 0.2727 repeating. And then I'm going to multiply by a power of 10. So that could be 10, 100, 1,000, whatever it is that will help me move my decimal place over, so that when I subtract, I can subtract away the 0.2727 repeating. And so if I just move my decimal place one space to the right, then I'm going to get 2.727, and that doesn't subtract away, right? So I want to move it 2 spaces away. And to do that, I have to multiply by, instead of 10, 100. So I'm going to say multiply both sides of the equation by 100. 100x equals, and then when I multiply the right side by 100, my decimal place moves 2 spaces to the right, and I get 27.2727 repeating still. Okay, and then we can go ahead and subtract my two equations. 100x minus 1x is 99x. And then 27.2727 minus 0.2727 is just 27. Divide by 99, and I have 27/99. That's my fraction, which we can also reduce in this case to 3/11. Okay, but see if you notice a pattern. Do you notice a pattern? 0.777 repeating as a fraction is 7/9. 0.272727 repeating as a fraction is 27/99. So what's the pattern? If it was 0.349349 repeating as a fraction, this is just going to be 349/9 0.99. Alright, and so some of you might have caught the pattern that is just whatever the repeating digits are over 9. If there are 2 repeating digits, it's over 99. And if there are 3 repeating digits, then it's over 999. And so whenever you're rewriting a decimal, a repeating decimal, as a fraction, it's always just going to be the repeating digits. As a fraction, the repeating digits over a 9 for every digit. Okay, so if it was 0.2222 repeating, this will be 2 over 9. If it was 0.4141 repeating, this will be 41 over 99. And if it was 0.231231 repeating, this would be 231 over 999. And then if you can simplify that fraction, you can simplify that fraction. Alright, so if you remember this trick, you don't have to do the whole equations thing, but that's why. Alright, so your homework last night, I said you could skip number 12. I want you to go ahead and finish your homework from last night, including number 12. And then you're going to work on the review packet for your Unit 1 test, Unit 1 review packet. We have one more lesson to finish in Unit 1 before our test. So there may be some problems on a review packet that you haven't seen, that you're not sure how to do yet, which is okay. But most of it you should be able to do. So it is a big packet. It's not due until the day of your test, and I will give you a little bit more time in class next week to work on it. But it is relatively long, so please get started. And what I'd like you to get done by next class is I would like you to at least get 1 through 19 done for next class. And that's everything that we've covered already. And then that way you can ask questions next time and you won't have as much to do next week. And I will have the answer key up by this weekend, so you will be able to check your answers.